Hello, this presentation is on derivatives of trigonometric functions. We're going to start with the derivative of sine function and cosine function. So what is derivative of sine function? The derivative of sine function is the rate of change of the sine function at a particular angle. Same applies to cosine function. The derivative of the cosine function is the rate of change of the cosine function at a particular angle. And it's the same for tangent, secant, cosecant, and cotangent. Now, we're going to be using a trick actually to determine the derivative of sine function, derivative of cosine, derivative of negative sine, and negative cosine. Let's use the unit circle. On the unit circle, the x-axis is the cosine axis, or the cosine axis is the x-axis. Now, this is the positive side of the x-axis, which means the positive side of cosine axis. And this is the negative side of the cosine function. So what we do, we write cosine on the positive side of the cosine axis and negative cosine on the negative side of the cosine axis. Same idea applies to the y-axis. The y-axis is the sine axis, and this is the positive sine axis, and this is the negative sine axis. So what we do, we simply write positive sine of x on the positive side and the negative of sine of x on the negative sine axis. Now the trick is the derivative of sine will be the cosine. So what we do, we move clockwise. So derivative of sine is cosine, moving clockwise. Derivative of cosine is negative sine, moving clockwise. Derivative of negative sine, negative cosine. Same thing, moving clockwise. And then a derivative of negative cosine will be the sine. This is the check. So moving clockwise on the unit circle, going to repeat, derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine, negative cosine, derivative of negative cosine is sine. So let's go ahead and fill in the blank. Derivative of sine we said is cosine. Derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is positive sine. All right, let's work on example 1. Example 1 says find the derivative of each function. The first one is y equals x squared sine x. So what we notice here, this is the product of two functions. The first function is x squared, second one is sine of x. So that means we need to use the product rule. So y prime equals the derivative of x squared times sine of x. Using the product rule, the derivative would be derivative of x squared times sine x plus derivative of sine x times x squared. What is derivative of x squared? That's 2x times sine of x. What's the derivative of sine? That's cosine times x squared. So it's 2x sine of x plus x squared cosine of x, and that's the derivative. Example B, y equals cosine over 1 minus sine. We have a quotient of cosine divided by 1 minus sine. So we need to use the quotient rule. So y prime equals derivative of the quotient, which is cosine over 1 minus sine, derivative. So the formula again is derivative of cosine multiplied by 1 minus sine minus derivative of 1 minus sine times cosine all divided by 1 minus sine squared. Okay. All right. So derivative of cosine is negative sine times 1 minus sine. Derivative of 1 minus sine, so derivative of 1 is 0, and derivative of negative sine is negative cosine. So we're going to write minus 0 minus cosine times cosine. And this is all divided by 1 minus sine x squared. Now, negative sine times 1 minus sine, that is okay. That's negative sine x plus sine squared. You just distribute negative sine times 1, which is negative sine. Negative sine times negative sine is sine squared, positive sine squared. And then minus 0, which we don't have to write it down, minus cosine, that's plus cosine times cosine. So it's plus cosine squared x. All divided by 1 minus sine of x squared. Now, there is something we need to remember is sine squared plus cosine squared is 1. Okay, so this equals 1. Sine squared plus cosine squared is 1. It's called Pythagorean identity. So it means it's 1, and don't forget the minus sign. So it's 1 minus sine over 1 minus sine squared. And obviously this simplifies to 1 over 1 minus sine. And that would be our final answer. Right, next thing would be the derivative of the other trig functions, which are the tangent function, secant function, cotangent, and cosecant. So what is derivative of tangent? Derivative of tangent is secant squared x. Derivative of secant is secant times tangent. Derivative of cotangent, negative cosecant squared x. Derivative of cosecant is negative cosecant x cotangent x. And we're going to derive each of these derivatives. However, it is much quicker to just memorize. Derivative of tangent, secant squared, and so on. We shouldn't, each time we need to use one of these derivatives, we shouldn't derive it. We just need to memorize it. But I'm going to go ahead and derive each of them. So what's the derivative of tangent? So the idea is I'm going to write tangent as sine over cosine, which is the quotient identity. Now, derivative of sine over cosine, we're going to use the quotient rule. So it's a derivative of sine times cosine minus derivative of cosine times sine. All this divided by cosine squared. Okay, now let's use the known information, which is derivative of sine. Derivative of sine is cosine times the other cosine. So derivative of sine is cosine times this cosine. Okay. Derivative of cosine, let's put a minus. Derivative of cosine is negative sine times the sine function. So this is negative sine times sine. This is all divided by cosine squared. Okay. Now, cosine times cosine is cosine squared. Minus is plus. Sine times sine is sine squared. All divided by cosine squared x. So cosine squared x. Again, we are looking at Pythagorean identity, which says cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1 over cosine squared. And what is 1 over cosine squared? That's secant squared. Why? I can rewrite this expression as 1 over cosine squared. And 1 over cosine is secant. It means secant squared, because 1 over cosine is squared. And that verifies the first one. Derivative of tangent is secant squared. So let's do the second one, which is derivative of secant. So derivative of secant, I can rewrite secant as 1 over cosine. So use the reciprocal identity. And then I apply the quotient rule. So derivative of 1 times cosine minus derivative of cosine times 1 divided by cosine squared. Now, derivative of 1, that's a 0, times cosine, that's a 0. So far we have a 0. Minus derivative of cosine is negative sine times a negative, it becomes positive. So if we write it down, derivative of cosine is negative sine times 1, all divided by cosine squared x. So negative is positive, so we got sine x over cosine squared of x. So far that's what we have. Now, this can be written as 1 over cosine times sine over cosine. Why is that? Well, cosine times cosine is cosine squared. 1 times sine is sine. Now I know that 1 over cosine is secant. And sine over cosine, that's tangent. And that verifies the second derivative, the derivative of secant. Let's do the cotangent. I'm going to use the same check. Cotangent is the ratio of cosine over sine. So we apply the quotient rule, which says derivative of cosine times sine. Well, the quotient rule says derivative of the numerator times the denominator minus derivative of the denominator times the numerator over the denominator squared. But I'm just using whatever I have in here. So derivative of cosine times sine minus derivative of sine times cosine divided by sine squared. Okay. Derivative of cosine is negative sine times sine. Maybe let's use different color. So derivative of cosine is negative sine times sine. Derivative of sine is cosine times cosine, all divided by sine squared. Now, negative sine times sine, that's negative sine squared x. Negative cosine times cosine, negative cosine squared x, all divided by sine squared x. Now, if I take the negative as a common factor, I'm going to have a negative of sine squared x plus cosine squared x divided by sine squared x. And what is sine squared plus cosine squared? That's 1. So that's 1. So it means, don't forget the negative, so negative 1 over sine squared. And what is negative 1 over sine squared? Well, that's negative cosecant squared x. And that verifies the derivative of cotangent, which is negative cosecant. We go back over here. Cotangent is negative cosecant. Let's do the last one, which is derivative of cosecant. So cosecant is 1 over sine. Okay. Cosecant is 1 over sine derivative. We're going to apply the quotient rule. So derivative of 1 times sine minus derivative of sine times 1, all divided by sine squared x. Okay. Derivative of 1, it is, derivative of 1 is 0. So that's a 0. Times sine, it's a 0. So far we have a 0 minus derivative of sine is cosine times 1. So simply minus cosine over sine squared x. So we have negative cosine x over sine squared x. This can be written as negative 1 over sine x times cosine over sine. And of course, sine times sine is sine squared. 1 times cosine is cosine, and you have the negative. What do we know about 1 over sine? That's 1 over sine, that's cosecant. What do we know about cosine over sine? That's cotangent. And that verifies our last derivative, which is derivative of cosecant is negative cosecant cotangent. Okay, let's work on example 2. Find y2 primes. Y2 primes means we find the first derivative and then the second derivative. So let's start with y prime. Y prime would be the derivative of secant. What is the derivative of secant? Well, we can just look at the table. Derivative of secant is secant tangent. Derivative of secant is this one over here, secant tangent. Okay, so we can use it directly. So the first derivative is simple, so we want to say, okay, what's that secant x, tangent x. Nice, it's all done. Now y2 primes, what this means, it means the derivative of the derivative. It's derivative of the derivative. So y prime prime. Okay. So what is y prime? Y prime is secant tangent. So it means I open parentheses and I write secant tangent and then take its derivative. Okay, because this one is this and then take the derivative of that. Okay. Now derivative of secant tangent, we have to use the product rule. So derivative of secant, let me write it. So derivative of secant times tangent plus derivative of tangent times secant. This is product rule. Derivative of secant is secant tangent times tangent. Derivative of tangent is secant squared x times secant x. Refer back to the table and you find these derivatives. Okay, good. Secant times tangent, that's secant x tangent squared x. And secant squared times secant, that would be secant cubed. Secant cubed, sorry. Secant cubed x. And with this, we have found the derivative, a second derivative of secant. Example 3. Example 3 says, find the equations, actually, it could be more than one, for the lines that are tangent and normal. Okay, so at least one tangent, one normal to the graph of f of x equals tangent x over x at x equals 2. At x equals 2. So usually when we write an equation of a line, we need two things. We need a slope and a point. Of course, this point has to be on the line. So if we have a point and a slope, then we're good. So do we have a point? Yes. I know that we want this tangent line that passes through the point whose x-coordinate is 2. That's what it says. So to find the y-coordinate that corresponds to x equals 2, we need to evaluate the function at 2. So it means y equals f of 2, which is tangent of 2 over 2. And to do this, let's use calculator and make sure that your unit is set to radian. So we go to mode. It is on radian. So we exit. Now we just simply, let's use the fraction. So we got tangent of 2 divided by 2. So it's negative 1.09 let's round to 3 decimal places. So negative 1.093. Okay, so negative 1.093. That's our y coordinate of this point. So let's write it down. Negative 1.093. So it means our point so far, our point is called P, is 2 comma negative 1.093. What is our slope? So the slope M is the derivative at 2. It means f prime of 2, which is derivative of tangent of x over x at x equals 2. This is the notation we're going to be using. So tangent of x over x, or the derivative of tangent of x over x at x equals 2. So for this, we're going to use calculator to find the derivative. So what you want to do, you want to go to math. And then if you look at the menu, number 8, it says the nth derivative. So you want number 8. Now it says d, which is derivative. And then on the bottom, it says d, and it's flashing a and then a box. So what you want to do is just type x. And then in between parentheses, we need to put the function, which is tangent x, tangent x. We need a fraction, of course. Okay, that's not going to work. So let's go back and delete. Okay, so we need the fraction. So alpha y for the fraction. So on top is going to be tangent x divided by x. That's the function. And then the last part is specifying the value of x, which is 2. Then you hit enter, and you got the derivative. So it's 3.433. Let's just take 3 decimal places. So this simply equals 3.433. Now I have a slope and I have a point on the line. So the equation will be y minus the equation of tangent line. So let's write first the tangent line equation. Y minus negative 1.093. That's simply plus 1.093 equals the slope, which is 3.433 times x minus 2. We can keep it like this, or we can simplify, either or. Let's keep it like this. Now for the normal line equation is y plus 1.093, same point, passes through the same point. However, the slope of the normal line is a negative reciprocal of the slope of the tangent line, because normal line is perpendicular to the tangent line. So it's a negative reciprocal of the slope of the tangent line, which is negative 1 over 3.433 times x minus 2. And we can put this in a box. We can simplify if we want, but we just keep it this way. So this is the end of this presentation. Thank you for watching.